Alright, what's up? Ms. Trine's back. We are going to tackle a system of equations. The first thing we're going to work with is, solving these systems with graphing. So there's a couple things you got to know first. One is, what is a system of linear equations? So, it's just with two or more linear equations. You could have them paired together. But the biggest thing is, what's a solution to a system of equations? Well, that's where the lines intersect. So if you have two lines, they're going to cross at some point unless they're parallel. Well, that's your solution, is where they cross. So to determine if a point is a solution, you need to plug that point into both equations. So let's go ahead and tackle example number 1. Remember, this is your x value and this is your y. Both are 1. So when we do our first one, you've got 2 times 1 plus 1 equals 3. Well, 2 times 1 gives you 2. Add 1, you get 3. 3 does equal 3, so that works, yes. For our second one, we'll have 1 minus 2 times 1, and it's supposed to equal negative 1. Well, we got 1 minus 2. It does equal negative 1. Negative 1 equals negative 1. Yep. So, yes, this is a solution. If we look at example number 2, we got to plug in negative 6, negative 4. Remember, this is our x value. This is our y. So, for our first one, we'll have negative 6 minus 3 times negative 4 equals negative 6. Well, our negative 6 we'll just bring down. Negative 3 times negative 4 gets you a positive 12. That equals negative 6. Well, negative 6 plus 12 gets you a positive 6. But it's supposed to equal negative 6. Well, that's not true. So, this is not a solution. This is not a solution. So now let's practice actually graphing them. You got a couple different steps. First thing is just to graph both the equations and then find the point where they intersect. So for the example here, it intersects at 3, 0. So for the first example, both of these are in slope-intercept form. And we know how to do that, thankfully from our last lesson, or unit, I should say. So for the first line, I'm going to do this one in a beautiful red. So it's going to start at 2, and it's going to go up 1 over 1. Or down 1 back 1. So we're graphing that inequality. There's our line, or not inequality, equation, in red. So there's our first one. Now let's do our second one. Well, I'll graph that one in a beautiful blue. So we're going to start that line at negative 2. Then we're going to go up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. So it looks like our line is about here. And you can see that they intersect at this point. So your goal is to just tell me what that point is. And that's 2, 4. Remember, this is your x, this is your y. You can always double check that and plug them back into both of your systems. But we can see graphically that that's where they're going to cross. So that's example number 1. Example number 2. So we can see that both of these lines are in standard form. So we know that we have to find what x equals and what our y equals. Or as we like to say, our x and y intercepts. So for the first equation, like I said, I'll do my work in red. We have to find out what x is. So to do that, we plug in 0 for y. So for our first equation, we'll have 2x equals negative 4. Well, now we have to solve for x. So divide by 2 on both sides. Our x-intercept is at negative 2. Now for our y, we have negative y equals negative 4. Well, to get rid of that negative, we'll divide by negative 1 on both sides. So our y-intercept is at 4. So there's our first one. Let's go ahead and graph that. So our x is at negative 2, and our y is at 4. So we're going to connect those two dots and add our arrows. Perfect. So now we're going to go ahead and do our second equation. So we'll do that one in a blue. So again, we got to find what our x-intercept is and what our y-intercept is. So for our x will equal -2. And for our y, we'll have -y equals -2. Well, got to get rid of that negative, so divide by -1 on both sides. So our y-intercept will be at 2. So x is at -2, y is at 2. So we graphed our 2 points. Let's go ahead and connect those dots. Perfect. I missed it a little bit, but we can still see that our solution is right there. That's where those two lines cross. And that solution is -2, 0. So the solution to the system is -2, 0. We've got a word problem. Don't be intimidated. All right. So the first thing we got to do is kind of read what it says, is break it down. So we've got scientists studied the weight of 2 alligators over a period of 12 months. So the initial weight and growth are shown below. So alligator 1, its initial weight is 4 pounds, and the rate of change or rate of growth is 1.5. So when we write that, we'll have y equals, remember, x is going to be your months, and y will be your weight of the alligator. Your weight. My pen is bugging out on me. All right, perfect. So, for the first one, A1, you'll have y equals, our rate will be our 1.5x, and then its initial weight is 4 pounds. So that's our first one. For our second one, our alligator number 2, we'll have y equals, our growth rate is 1x, and it starts at 6 pounds. So now we have to graph those two things. So let's go ahead and graph the first alligator. So you start at 4. Our slope is 1.5, but let's convert that to a fraction. That's going to give you 3 halves. So you're going to go up 3, 1, 2, 3, over 2. Up 3, over 2. Or down 3 and back 2. All right. So we got our points. Let's go ahead and draw our line. So there's alligator 1. Now let's go ahead and graph the second alligator. So remember, that one's going to start at 6. And it's going to go up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. Uh-oh, we see the overlap. That's perfect. That's what we want. So we'll draw our line. And you can see that the weight of these alligators will be the same at that intersection point. So that point is 410. So what that is saying is that at 4 months, they will weigh 10 pounds. And that's kind of cool to see. Gotta love some alligators. All right, let's keep going. There are a couple different possibilities when you are working with a system of equations. You can have infinitely many solutions, and when you graph it, that's just going to be the same line. Or you can have no solution, which just means they're parallel lines. So there will also be those types when we're moving on throughout this unit, and it'll be important to remember, well, what does it look like graphically? So let's go ahead and tackle example, or I guess these two examples are not numbered. All right, so for this first one, we'll graph the first one in red. So remember, you got to find your x and y values. So x will be at -3, and y will be at 3. So x is at -3, and y is at 3. Remember, we're just getting that from our standard form. So draw your line. So there's our first one. Now let's go ahead and look at our second one. We'll do this one in green. Get a little Christmas up in here. So remember, you're plugging in 0 for the value that you are trying to solve for. So for the first one, we've got, if we're looking for our x value. So that's 2x equals negative 6. Divide by 2 on both sides. So x will be at negative 3. Your y value, you have negative 2y equals negative 6. Well, divide by negative 2 on both sides, and y equals 3. So our x is at negative 3, and our y is at 3. And you can see, aw snap, they're the exact same line. So that means it has infinitely many solutions. Perfect. So that's the first one. The second one, let's go ahead and do that same process. So we got to find our x and y. So we'll do pink for this first one. So our x will be at 1, and our y is going to be at 3 halves. Remember, you're just plugging in 0 for x and solving for y. So x is at 1, and y is at 3 halves. Remember, that's the same thing as 1.5. So that's about right here. So let's go ahead and draw our line. Looks a little something like that. So now for our second one, we'll do this one in red. So x will equal negative 4/3, which is the same thing as 1.3, never be intimidated by fractions, and y is going to get you negative 2. So y is negative 2, and x is negative 1.3, which will be about right here. So if we draw those lines, you can see, hey, they are parallel. They are not going to cross. All right, perfect. So let's go ahead and go to our front page and check off our first objective. We did it. We graphed them with infinitely many solutions or no solutions.